And it's good morning to Professor Cath Noakes, who's from the Institute for Fluid Dynamics at Leeds, and of course a member of SAGE. And welcome back, Cathy.
Thank you. Good to be here.
It's great to see you again. I understand that you've got to go and speak to the Scottish Parliament at 25 minutes past, so we're a bit short, so I'm going to get out of the way. You do your presentation, and then we'll come up to Q&A.
Okay, thank you very much, David. Okay, so hopefully you'll be able to see some slides from me. Okay, right, go back one. Okay, so thank you very much for inviting me to talk this morning. I'm going to talk a little bit around some of what we think we've learned from COVID and talk about a piece of work from the Royal Academy of Engineering looking at infection-resilient environments and thinking a bit about the longer-term challenges alongside some of the difficult things we've got to still deal with now. I think I want to start by saying, actually, although COVID's thrown a huge focus on ventilation and the environment, in a way, it's nothing new. We've known that the environment affects our risks of infection for well over 100 years. We go back to Florence Nightingale. She noticed that the soldiers in the Crimea wore the rates of transmission of hospital infection were associated with the environments they were in. And she advocated for high ceiling spaces, large rooms, large windows, plenty of fresh air, plenty of natural light, good spacing between the beds. And all of those things reduce the risk of transmission of infection. And we can look at lessons from, the influenza pandemic in 1918. We can see that made shifts in building design in some countries where, greater focus on ventilation and a recognition that these respiratory infections travel through the air, and then hence the environment matters. But we are not very good at necessarily remembering this. And I think we've spent a lot of time focusing on energy and not necessarily thinking about the environment. So it's come back to bite us. And that means that the pandemic has perhaps really shaken things up. And I hope it shakes things up for the better. But some of the key things that I think it's really focused on is making us explore in a huge amount more detail transmission of the disease. It's making us think about why we are having to rely on very short-term actions. We're recognizing that behavior interfaces with all of the technology, and I think it's exposed a lot of strategic weaknesses in our built environment and in how we have designed and how we respond to quality of our environment. So I'm going to talk through a few of these things, and particularly through the Royal Academy of Engineering work. I think a lot of people here are probably aware of this now, but if we think about how the virus actually transmits, it's a respiratory virus, hence the virus itself is within aerosols and droplets that are released when we breathe, talk, sing, cough, sneeze, etc. Some of these are very small aerosols. They can remain in the air for long periods of time and transmit through inhalation, through what we'd call a classic airborne route. And probably the biggest risk for transmission happens when people are at fairly close proximity, within sort of 1 to 2 meters of each other. And transmission there is very complex. It's via both the very smallest aerosols and the larger aerosols and the bigger droplets. And that can include inhalation and direct deposition of droplets into the virus onto mucous membranes. And then, of course, probably a more minor route, but we still think it plays some role in transmission, is the larger droplets and contaminated hands that touch surfaces and allow transmission via contaminated hands to the mucous membrane. And we don't yet know all the different balances of these routes. We don't quite understand exactly when and how they all occur, but we're getting better information on these. And I think one of the reasons we don't understand it all is it is very complex. It's a complex interaction of the virus, human behaviour, and fluid dynamics. And the fluid dynamics and aerosol science is thinking about various different sizes of droplets and aerosols, how they behave in air, and how they might carry virus between two people. And this diagram just illustrates some of the different sizes of respiratory particles that we produce and how they might affect people at both short range and at longer distance. But over the past 18 months, we've identified a number of risk factors which relate related to the transmission of the virus. So we know that there is a much higher risk in spaces where you've got high occupant density, where you've got poor ventilation, in spaces which people share very highly together, whether that's a household or a workplace or a school. And we also know there are some relationships with temperature and humidity. It's a little bit unclear exactly how big a role, for example, humidity plays, but it certainly does seem to play some role. Very difficult to work that one out, though. We also know there's a whole raft of human factors, and these are probably harder to deal with. So some of these relate to human activity. We know that if you are more active, so you're doing physical activity, or you're singing, or you're breathing at a higher rate, or talking continuously, you're at more risk of transmitting the virus. You produce more aerosols. Some things are obvious, like if you're exposed to people who are infected for longer periods of time, just the probability that you pick up enough virus to become infected yourself goes up. But then there are things around socioeconomic factors, workplace factors, how frequently we contact different people, all of which relate to transmission. And then people's hygiene behaviours. So we see some people will wear a mask, others who won't. Some people who will isolate when they're sick, others who are still out when they're clearly unwell. But from a built environment perspective, the built environment's part of this, but it's not the only aspect. Buildings set the conditions, they enable their interactions between people, but they don't manage those factors. And I think it's really important to remember that we can have a very well ventilated building, we can set things up very well, but it's human behaviour and how people interact that will ultimately determine a lot of the risk that happens in reality. If we're thinking about how to manage risk, we can look at various different approaches. So one that's been advocated quite a bit is thinking through the hierarchy of risk controls approach. This one is something that's more widely used in health and safety circles for exposure to hazardous substances. I think it works to a point with a virus. I think it allows you to think through, for example, how can you eliminate virus? Well, if people are working at home, for example, then or people are just not doing a particular activity, then it eliminates the chance of transmission. I think the engineering controls are relatively straightforward in this one. Administrative controls are quite a tricky one, and there is a danger we put everything into administrative controls, even things like workplace testing, which of course some people think is of elimination, but it isn't. It is, because it is imperfect. The other challenging one is where do we put things like face masks and face coverings in there. So if people are wearing proper respiratory protection to protect themselves, then that comes as PPE. And it sits at the bottom, not because it's ineffective, it's often incredibly effective. It sits at the bottom because it relies more heavily on human behaviour. However, face coverings, I've put them with a question mark because it's a really difficult one to know where they go because they act as a source control. So are they actually an engineering or admin control, or are they still, they're not PPE in that sense? So one route in which we can look at managing a framework to think about risk in a building. Another framework we can use is to think about how mitigation measures relate to different routes of transmission. And a slightly messy diagram this, but it does illustrate how different measures act on different routes of transmission. So for example, ventilation acts on the very top line of this diagram, whereas cleaning hands acts just on the very bottom triangle of this diagram. And if we want to mitigate transmission, we need measures that essentially block all of the routes. You'll see face coverings feature in multiple places because they block at source and they block at the susceptible person. Of course, they're imperfect as well. All of these measures are imperfect. And then we need to add multiple measures together to get the best protection that we can. We can also look at something known as the Swiss cheese model, which I rather like this one. The idea is that you've got lots of different layers of protection, but again, they're all imperfect. They've all got holes in them, and you have to line enough up to block the holes. And that's ranging from some of the personal responsibilities through to shared responsibilities. So ventilation very much comes into shared responsibilities. You'll notice there's a little mouse in there. The mouse is the misinformation mouse. And there are various versions of this diagram. The more recent ones have more misinformation mice in them, nibbling away at some of the layers of protection, creating doubt and creating new holes. So we do know things. We know how to mitigate this virus. We know how to mitigate other viruses too. Why are we not doing this effectively enough? And this is where the Royal Academy of Engineering piece came in. So this was a commission from Sir Patrick Vallance to the Royal Academy of Engineering, who ran this through their National Engineering Policy Centre and in collaboration with CEng, and looked at both the strategic challenge, how can we make buildings more resilient, and the immediate action, what needs to be done now. And in order to run this, I was one of the members of the expert group who sort of led on putting together the report, but we also conducted evidential hearings. So there were 14 evidential hearings with various owners and occupiers of different buildings across multiple different sectors, including various workplaces, healthcare, transport, etc. And I think one of the things that really came out when we looked at those evidential hearings was a very big range in knowledge and understanding. So some organisations had a really good grasp on things. They understood the different transmission routes. They understood what to do. Others really struggled. They found that there was a lot of varying guidance out there, that was complex. It could be misinterpreted. There were different ways, different guidance in different places, and it was difficult to know what was the right thing to follow. Ventilation was a challenge, and I think those of us who work in ventilation forget sometimes. We understand it, or we think we understand it. We probably don't fully. But organisations which said they don't know what good ventilation is, they've had lots of different metrics stated. They struggle to figure it out. And then others, the bottom quote, which is talking about the fact that they focus still quite heavily on treating surfaces, not so much because they know it's the biggest issue, but because it's reassuring for customers and colleagues. It's very difficult to say we've increased the supply air rate in a building and people to know what that means and believe it. And then the other big thing that the report sort of pulled out, which I think again a lot of us are well aware of, is this a larger strategic problem. And I think this goes well beyond just ventilation in buildings. I think this goes right across the sector. It relates to building safety, and I've put a quote there from the Hackett report, which focused predominantly on the Grenfell inquiry. But there is a legacy of poor performing buildings that maybe they were poor in the first place, or it may be to do with maintenance, retrofit, changes in occupancy and over the years. But we do have, I think it's important we probably recognise this, there are some systemic issues which mean that many of our buildings don't comply with what they should do. And we have a lot of buildings which are underventilated, and there's really not an excuse for it. They just do not have what they should have. You start to recognise things like technology solutions, which should be very good, but they haven't considered how people use them. So people switch them off, people don't know what to do, etc. And then I think there's probably a long legacy of addressing problems in isolation, and particularly thinking about addressing energy performance of buildings, but without necessarily thinking through the health consequences of that. And ultimately, I think we probably all will need to look at things around training and skills. But this all came out in this report, where there's a whole raft of things that I think as a sector we'll need to get to grips with. So the report put out some different recommendations from an immediate perspective. The focus was predominantly on communications and guidance. So making sure that people were aware of clear information and were supported by the right baseline technical knowledge to be able to take suitable decisions. And this wasn't necessarily really high-end specialist technical knowledge. This is sort of baseline for owners and occupiers to be able to manage risks and select appropriate things. The report also recommended incentives in there to encourage particularly the really poorest performing buildings to improve their environments. But then we also identified a number of recommendations from a strategic challenge perspective. So particularly looking at how we map knowledge and skills. I mean, one challenge in here, which I think we probably all recognise, is that infection control has never been part of the building designing ventilation and building services in the majority of buildings. It's been quite a key focus in healthcare, and of course we've had some very specific focus like Legionella, but you know, sort of the wider focus has been much more on comfort and energy, and more recently air quality, but less so on infection. But I think we need to look at how we then, where we have got skills and knowledge, where we haven't, and how we can put sort of better training and things in place there. We recognise there were gaps in research which need to be carried out, and recognise that there were gaps around our capacity, capability to enforce standards and to demonstrate how we should underwrite the right regulation and enforcement to, for example, for minimum standards, say on ventilation. And then the other thing that we highlighted in the strategic challenge was that this has all got to be tied in with net zero. There's a huge focus, you know, especially this week with COP26 happening around net zero, but we cannot just make buildings comply with net zero by sealing them up. We have to make sure they're ventilated as well, and have to make sure we balance the needs of people and the needs of the environment together. So where have we got to with this? I think there has already been quite a bit of progress. The report came out in July. Over the summer months, there was quite a substantial amount of change on government guidance. So both the Health and Safety Executive guidance on the left and BESA guidance on the right, both really put some significant input into highlighting the importance of ventilation and putting some clear guidance on how to identify poorly ventilated spaces, what to do, and so some examples in there. So there's some actually really good, clear and consistent guidance now across from the government departments. There's also been actions by the various other organisations. So CEng have done a really nice guide on air cleaning technologies and maintain their guidance up to date on ventilation for buildings. British Occupational Hygiene Society have produced a tool called Breathe Freely, a ventilation tool. It's quite simple. It doesn't do all the physics of ventilation, but it allows that immediate assessment of, well, which spaces do we think we might need to do something a bit more about? But the longer term problem is a more difficult one. And I think one of the first questions is, if we are to look at that long term strategic challenge, what is a good environment? And first question is, well, what is actually the ventilation rate in most of our buildings? I imagine a lot of people listening to this know what their ventilation rates are in their buildings, but many people don't. And it's very hard to measure accurately, and especially in naturally ventilated buildings. But then even if we know what it is and we can measure it, being able to say what is the right ventilation rate, right metric for health in a building is not easy. It's very difficult to relate ventilation rates to health consequences. And then we also have a challenge around ventilation linking into behaviour. So a lot of people, a lot of buildings rely on opening windows. People's motivations for opening windows are usually not around air quality. They're usually much more around comfort and noise and security. And we do need to, and cost of heating and things, we do need to think much more about the motivations for why people ventilate spaces and how people interact with the systems in their buildings. If we start looking again at history, how do we ventilate for health? Well, if we go back right to the very beginning of ventilation rates, Treadgold was the first to calculate ventilation rates, suggested we need 2 litres per second per person for metabolic needs. We then go into an era of around Nightingale's era, but Billings suggested that we needed 14 litres per second per person. And that was probably the only time in history where disease has dominated the rationale for ventilation rates in buildings. But then as we get technology advances, we get air conditioning and mechanical ventilation systems come along, we can see that the standards change. We can see we now focus much more on odour and comfort. We tend to drop our ventilation rates when energy becomes a primary focus. We see they increase slightly with smoking, and we've sat at around 8 to 10 litres per second per person for probably 30 odd years now. Both ASHRAE and CEng have a similar value, and that's focused around comfort and air quality. But I do think there's a question mark there. There was a review done in 2011 which suggested we should have substantially higher rates of ventilation for health. But it's very difficult to show a direct cause and effect there. There is quite a lot of evidence, though, that we know buildings improve health. There's good research that shows that if you have a better ventilated bedroom, you sleep better, you'll perform better the next day, that test scores in schools go up, absenteeism goes down. If you have better ventilation, it improves mental and physical health, improves respiratory symptoms. Some research from Denmark, which suggests that poor indoor air quality can reduce productivity by up to about 9%. So if you imagine in a workplace, that's nearly half a day a week of productivity that you're losing because of poor air quality in certain places. Go back to just before the pandemic, 5.3 million work days lost due to respiratory infections in the UK. It's huge numbers, and that is a bottom line impact on performance of many businesses. And then if we go data from the US, calculations from over 20 years ago suggested the annual gains from better indoor air quality could be huge, over $40 billion a year. So you could argue we should be doing all this already. We have some data. The problem is, I guess, it's not as tangible as your energy bill. And we have all these competing priorities. I think we probably in this forum know them all very well, but I think all of these things do come together. And somebody commented this one to me the other day about the term value engineering as being an awful term, because I don't think I've ever seen value engineering increase the cost of a project to make it better value. It's always about removing cost, and it nearly always means a worse project as a result. I've touched on behaviour a little bit already, but I think this is, again, a really important part of it. From a ventilation perspective, the dream of policymakers is that we can find a magic bullet. We can find a simple message, a bit like wash your hands. It doesn't exist for ventilation. Public knowledge, ventilation has been distilled down to open a window. If you've got a window that opens, you've got ventilation. Again, we know that that's not true. It's more complicated than that. And we also have issues which we've raised already around awareness, around skills and capacity, and I think fear of consequences. People don't necessarily want to look because they're worried about what they might find. There are things that we're doing to address some of the knowledge gaps. There's a big project which was called the Protect National Core Study on COVID transmission, where we're trying to understand some more about the complexity of the interactions between the virus, the environment, and human behaviour. And that is feeding directly into some of the policy work. I think that might be my last It seems to have stopped moving the slides forward at that point. I'm not quite sure why. So I was going to say what I was going to say, and just to finish up, I was going to mention as well that we have another project which is looking at, we have a network called the Breathing City Network, which is looking at the interface between indoor and outdoor air quality. And then I think just to sort of finish things up, we still have an awful lot of unknowns in there. We know a lot. We don't know very much about the virus characteristics and how we emit. We don't necessarily know all the factors about different transmission routes, and don't necessarily know how much all of the routes of infection, the mitigations change the routes of infections. But I think we do need to think about how we can use what's happened over the past 18 months to look at a change in the way we think about design, maintenance, retrofit, and think much more about a human-centred design approach. Buildings are there for people. They're not there as things to cost you money. They're there for people, and therefore having health-based metrics together with our sustainability metrics, I think, is an important way we should try and move forward. And we need to think through the whole picture, from the skills and knowledge into design, into technologies, into post-occupancy evaluation, into then maintenance. And I'll leave it there. I don't know what happened to the slides, but hey. Okay, David, are we over to questions?
I think so, but can you hear me? Can you hear me?
I can hear you, yes. Yes.
Yeah, technology. Who relies on
brilliant.
technology? So my apologies for that. And the slides will be available. There's already been one question on that. You made the point, I think, about the reports that were produced. How do ventilation contractors become part of that kind of knowledge sharing process and the development of best practice? Because the Royal Academy report, for example, lots of designers in there and lots of building owners, but installers have that insight into, but clients will never buy that. They'll never do that. I'd never win a job if I did everything that the designers insisted upon, because they don't see the value in it. If they succeed, they're not aware of what has been done because they can't see it, feel it, touch it, and they're not hot, they're not cold. So how do we get involved in that debate?
Yeah, I think, so there's two things in there. I think, first of all, it is a real challenge that, how do we make the case for better ventilation in a building? And I can see it in my own organisation that, what would we do next if we've got money to spend? Will we spend that money on retrofitting better ventilation systems, or will we spend it on technology for hybrid lecture delivery, which would be much more visible? The students won't notice the ventilation because it's there in the background, even though actually I'd argue it's more important. I do think we need ventilation contractors in the debates, absolutely. And I think that's one of the things that we need to think about going forward, is how do we make sure we engage the right people, and make sure that there is another phase of this work, and make sure that the second phase engages with everybody across the sector, because I think it's something that we are going to have to work out how we do this together. And it's one thing identifying there are problems, but it's another thing thinking through the solutions. And I do think that interface between what's what works in theory and what works actually in practice, and the complexities of delivering something in practice when actually spaces are not idealised at all. They're messy, and particularly retrofit spaces are a nightmare. And every single one of them is different, and every single one of them needs the right specialist knowledge to design the right solution for those spaces.
Yeah. I mean, as an industry, we install products, and I suspect ventilation will go the same way, that we'll install the products but not work out whether or not it's actually working and doing the thing we wanted it to do.
And I do think there we need perhaps a bigger focus on post occupancy evaluation or post fitting to monitor, to identify what works and what doesn't. Because I think we do lack knowledge on that, and in some cases we have more knowledge on some of the new stuff or some of the more advanced technologies, and we can say, oh look, this didn't work very well, but actually when you compare stuff to some of the stuff that really exists already, it's probably still far better, and we just need to have a better understanding of how the different technologies all work together.
I think that's somewhere where we can really help on that. A couple of questions from the floor now. So do you think there is a broader view emerging that natural ventilation is poor by definition, led by the pandemic? Is it really possible, likely, that technical handbooks are going to be updated accordingly?
So I think natural ventilation, I wouldn't dismiss it, but I think there are environments where it becomes more challenging. And I do think if we are serious about net zero and good buildings, we are going to have to think about probably more hybrid systems. So to enable that, it's very easy to naturally ventilate your house in summer, albeit sometimes you don't get the flow because there's not enough movement to drive it. It's very hard for people to naturally ventilate premises in winter. And I do think that we're going to have to think more carefully about heat recovery systems and hybrid approaches in buildings. And I do think that's going to have to be reflected in design handbooks in different places as we go forward.
Another question from the floor, which is a bit like we assemble products bit, but does Professor Noakes think that there has been a lack of professionalism and or lack of specific sector identity in the ventilation industry, and that has held progress in ventilation back? I guess that typically an electrician will install ventilation in a house and flick the switch and it's on. Whether it works or not is irrelevant. It's on, it's there.
Yeah, I mean, I think I wouldn't want to tar the industry with a single brush, because I think there are some incredibly professional organisations out there who do a great job. I do think that you're right that there are expectations over training and accreditation for somebody who's installing electrical systems, for somebody who's installing gas systems. We don't have the same level of expectation of accreditation for somebody who's installing ventilation systems. And that probably means there is more variability in that. I think, there are some very responsible organisations out there who've done a fantastic job. I have also seen over the course of the past 18 months, people in some organisations jumping on a bandwagon and using this to try and sell products, which some of them I would describe as snake oil. And so we do need to make sure that actually perhaps we have, some sort of codes of conduct, sign up that and recognition as well that there's no single good solution. We have to not say, okay, every organisation wants to say my product's better than their product, but we have to make sure we don't sort of champion one thing and dismiss everything else, which I think there is a tendency to do that in some places. And I think we have to perhaps be supportive of the whole range of solutions and recognise that everything is imperfect in some ways.
Here's one I think right up your street. Will fluid simulations enable the decision makers to retrofit and validate their solutions?
No, I don't think they will. I think they will help. I think they can tell us how some of the complex variables interact together. They can tell us things about things that we perhaps can't see, and I think they can help inform. The problem with a fluid simulation is it is an idealized scenario, and real buildings are not idealized. So I think it can help us along the way, but nothing beats some real world measurements and some real world knowledge and that you cannot put that complex human behaviour and real-world fluctuating environments into complex fluid dynamic simulations. So we need to bring all of our tools together. There's no one answer.
Right. Very short one. How do you define fresh air?
That's a very good question. So I'm aware that air is not fresh for a lot of people. And in many places when we come to talk about COVID, I would call it outdoor air rather than fresh air, because it's not always fresh. Although from a public perspective, when you're trying to get a simple message across, actually fresh air is just a simple message. But yeah, I think that is another big challenge, in that we need to think, we need action on outdoor air pollution to enable us to ventilate buildings safely, because many of our systems, although they're good at, they can mitigate indoor sources, in doing so they bring in outdoor sources, and even systems with filters, etc., will bring in odor, will bring in nitrogen dioxide, which, you know, the way to tackle that is not to put better filters in buildings. That might be a short-term solution. The way to really tackle that is to remove the sources, which is the outdoor sources.
Is it unrealistic to think that regulation will be the driver for better thinking about ventilation?
I think regulation has quite a big part to play. I mean, we can all grumble about regulation, we can all pick holes in it, but at the end of the day, when regulation is there and it's enforced, it does usually make a difference. I do think it is one driver, but I think we ought to be thinking about other ways in which we can demonstrate best practice. And some of this is not going to be about showing that you've complied with a regulation. It's about being able to show a client that actually there is a real cost benefit from having a better ventilated environment for their employees, and for the health and well-being of people. And it's a really hard thing to put numbers to.
Do you think, therefore, that the indoor air quality monitoring is really a first step to enable better solutions?
Yeah, I do think indoor air quality monitoring has a lot to tell us about this, because I think it's starting to make people aware of their environments and aware of what works, what doesn't work. I think there's still some way to go, but and of course we have to be careful we don't just jump on a number. You know, you can measure carbon dioxide in a room, you can see a high number and you can go, oh God, look, poor ventilation. Not necessarily. It might be a change in occupancy that's done that. It might be the fact that everybody's been for a run at lunchtime and they've all come back in the office and now their metabolic rates are higher, so they're breathing out more CO2 for a short period. There are reasons why you get high spikes in CO2, and we have to be careful that we don't just sort of jump on threshold values. But I do think if we get better monitoring in place, it helps us understand how our environments are behaving and how people are interacting with them.
We've got some really tough questions coming in, actually, so you don't have to answer this one. Have your SAGE colleagues got the message about ventilation now?
SAGE has said ventilation since April 2020. It's been in. If you look in all of the SAGE documents, you'll find ventilation is in there. Since then, it's become it's featured more regularly since from about June, July 2020. But of course, remember, SAGE gives advice to policymakers. It's then the decision of policymakers to do something with that advice.
Jacob Rees-Mogg said in the Houses of Parliament the other day that actually they don't need to wear face masks because we all know each other. Does the the virus discriminate then between people who know each other and don't know each other?
No, I think he might be wrong. The fact that you are more likely to catch this virus from somebody you know than somebody you don't know.
Yeah, I thought that might be the answer.
I'm not going to say any more about Jacob Rees-Mogg.
No, I thought he might be wrong. Is regular maintenance really important, particularly with things like filter changes and ensuring that systems are clean? Isn't that a really key factor that people normally neglect?
Yes, I think so. So I think it's, and obviously mechanical systems need maintenance, but I think people forget you also need to maintain your natural ventilation. So just think about how many buildings you've been in where the windows should open, but they don't. And they don't because they've been painted shut, or they've been deliberately sealed shut to save energy. Or we've had secondary, like my office here, I've had secondary glazing installed. It's heavy. I can't reach it. It's, we've had a lot of energy measures put in place, which means that we don't necessarily, aren't necessarily able to use properly the systems that exist.
Well, our time is nearly up, and I'm conscious that we can't keep the Scottish Parliament waiting. So, final question. Are you optimistic about the future for the ventilation industry? Where do you think we go from here?
I am. I think this is a real opportunity. This is like I never thought that I'd ever see a Prime Minister stand up and talk about ventilation, and the Chief Scientific Advisor talk about ventilation. And I do know that, COVID has brought this to the fore, but there's a wider interest there. So I know that the Chief Medical Officer, Chris Whitty, has a real focus on air quality and air pollution and the impacts that has on health, and particularly children's health and the health of vulnerable people. And actually, things are all starting to come together, which say we need to pay more attention to ventilation. My worry is that people will say, we'll get to the spring and somebody will go, oh, it's over, we'll forget about that now. And we need to make sure that it doesn't get forgotten, and that we translate what we've learned from COVID into planning for future pandemics and dealing with the wider questions around air quality and health in buildings.
Professor Cath Noakes, thank you very much. Your insight and knowledge is always incredibly valuable. And thank you for all the work you've done to promote the ventilation sector. And now we'll let you go and talk to the Scots. So thank you very much.
Thank you very much. It's been great talking to you again this morning, David. And
great.
Thank you to everybody. Yes.
Okay,
Goodbye.
So we're moving on now in Theatre 1. If you stay with me, we're doing modern slavery and exploitation in the supply chain. And Theatre 2, getting back to energy efficiency. Take your pick, I won't hold it against you, whichever one you go for. See you shortly.